Hey guys, in this video, we are going to be talking about writing systems of inequalities and using DESMOS to find the solution to that system, as well as talk about what some of the solutions mean in the context of the problem. So let's dive in. A family and consumer sciences class is making pillows and blankets to donate to a local shelter. The class has a total of 40 yards of fabric to use. Pillows require 1.25 yards of fabric and take 1 hour to make. Blankets use 4 yards of fabric and take 2 hours to make. The class has 28 hours of class time left to make the pillows and blankets. Let X represent the number of pillows they make and Y represent the number of blankets they make. All right, so the first thing we're going to do here is we're going to write the system that represents this situation. All right, so we've got two things going on here. We've got pillows, we've got blankets. We know that each one takes a certain amount of fabric and a certain amount of time. When I'm writing these kinds of inequalities, what I like to look for first is any kind of total that we have, or decide, am I comparing two groups of things that are doing the same thing, okay? So here I know that it's two different groups, right? We've got pillows and blankets. But it does say that I have a total of 40 yards of fabric to use, okay? I also know that the class has 28 hours to actually do all this work. So one of my inequalities is going to be all about the fabric, and one is going to be about the time. So let's start with the fabric first. So we know that X represents the number of pillows, and each pillow is 1.25 yards of fabric. So that means if I take 1.25 and multiply by the number of pillows that I make, I will get the total amount of fabric needed to make those pillows. And then if I add that to how much fabric blankets need, which is 4 yards, so 4 times the number of blankets would give me the amount of fabric needed to make those blankets. Now, I know that I only have 40 yards. That's the total that's going to go on the other side of my inequality. So the last thing I need to decide is, which way does my sign go? So this side of the inequality here, the 1.25x plus 4y, is how much fabric the students will actually use. Now, we know that this amount cannot be bigger than 40, so I'm going to use a less than symbol. However, it can be exactly equal to 40. If they get lucky, they'll use every scrap of fabric that they have, so I'm going to put an or equal to. Now, my second inequality has to do with the amount of time. So I know that blankets require 2 hours to make, so that would be 2x. And I know that, blankets is y, so that's actually going to be 2y. I know that pillows, on the other hand, require 1 hour, so that's 1x or just x, okay? And I know that they have a total of 28 hours. Now, once again, the left side, x plus 2y, represents how much time they actually take to make the blankets and the pillows, and that cannot be bigger than 28, so I'm going to use less than. However, they can use every single second available to them, so I'm going to make it or equal to. Okay, so that's our system. Now, what we're going to do here is we're going to use DESMOS to graph this. In another lesson, we will learn how to do this by hand, but for today, it's just an introduction, so we're going to use DESMOS. So let's take a look at how that works. Let me try and put this into focus. Okay. All right, so I'm going to take the system that I just wrote, and I'm going to type it into DESMOS. So we have 1.25x plus 4y is less than or equal to 40. Okay, and we'll worry about zooming later. Let's just get both of these in here. So we have x plus 2y is less than or equal to 28. Okay, so now, right now, we can't see anything. It's just a big blue blob. So I'm going to take my cursor here, and I'm going to zoom until I see this system, okay? All right, so here's what matters anyway. We only care about the positive section because they cannot use a negative amount of time or a negative amount of fabric. So I'm only focused on this first quadrant here, okay? Now, notice that I've got some red and I've got some blue going on here. The red has to do with my first inequality, which is the amount of fabric that they use. Now, if you remember when we talked about inequalities the first time, we said that the shading represents all of the solutions. So that means from my line here, the red line, the red shading represents the solution. So that stretches from right in here, right in here, from this part of the axis all the way to the x-intercept, which is 32, okay? Now the fabric inequality is the blue one. So that stretches from here all the way to here, and then all the shading that you see in blue would be the solution. And obviously we would ignore the shading that is negative. Now here's the difference when it comes to a system of inequalities. Much like a system of equations is where the lines intersect, the solution to a system of inequalities is where the shading intersects. So we are looking for the part of the graph where I have both red shading and blue shading, because remember, that's where the solution for an inequality is. It's in the shading. So if you recall, we had red and blue in this section right here, okay? So that's where all my solutions lie. So the third question that was on the slide said, give 3 combinations of pillows and blankets the class could make. So I need to choose ordered pairs that are in this section that is both blue and red. So let's take a look at the scale first of all. So I know that this right here is 10. It's hard to see, but there's a line here that's 2, 4, 6, 8, 10, and the y-axis is doing the exact same thing. So I'm gonna pick some points here, and I will write on the paper what types of combinations you could write. So for example, again, X is pillows and Y is blankets. So they could do 10 pillows and 2 blankets, 10, 2. So 10 pillows and 2 blankets is one option. They could do, since my lines are both solid, they could do no pillows and 10 blankets. Or if they wanted to go the opposite direction, they could do, let's see if it, yep, they could do 28 pillows and 0 blankets. Okay, so again, I'm just selecting points that are in the region here that is both blue and red, okay? The y-intercept here for the red line is a solution, and the x-intercept for the blue line is a solution. Notice that the x-intercept for the red line is over here, and this whole section is only red. It has to be red and blue. So this like darker area here that doesn't really look red and doesn't really look blue, it's almost purple, which would make sense. That is where all the solutions lie. So I'll let you take a look at the paper that I have, or what I've written down on the paper. I will refocus as well. Okay. That did not make it better. All right, so here's what I wrote. 10 pillows and 2 blankets, 0 pillows and 10 blankets, 28 pillows and 0 blankets. All of those are a solution here. This is actually problem 3. Problem 2 was putting the system into DESMOS. All right, let's try a similar problem. Okay, Aisha works at a bakery. She's able to work up to 20 hours each week. For the morning shift, she earns $14 per hour. For the afternoon shift, she earns $10 per hour. Aisha needs to earn at least $150 this week to pay for a trip she's going on with her friends. Let X represent the number of hours she works on the morning shift, and Y represent the number of hours she works on the afternoon shift. All right, so once again, we are going to write the system, and then we are going to put it into DESMOS, and we are going to find 3 combinations of hours that she could work on each shift to reach her goal. Okay, so we have a lot going on here. She can work up to 20 hours, and she earns a certain amount of money for each type of shift. More hours for the morning. I assume the bakery is busier then. And she has a total of 150 that she wants to make, or at least 150. So once again, I have 2 different totals. So we have up to 20 hours and at least $150. Okay. The 20 hours comes from how much time she spends in each shift. okay? So X is the number of hours she works on the morning shift. So if I take the number of hours she works in the morning and add it to the number of hours she works in the afternoon, I know that that amount cannot exceed 20 hours. That means it has to be less than. It could be equal to. She could work exactly 20 hours, but it cannot be bigger. Okay, now I also know that she earns $14 every hour that she works the morning shift. That would be 14x. And I also know that she earns $10 per hour for every hour she works on the afternoon shift. And I also know that she wants to earn at least $150. That means the amount of money that she makes can be bigger or equal to that $150. That would help her reach her goal. All right, so let's shift back to DESMOS. You're gonna see the problem we just did in the first one before I delete it. Let me refocus. Okay. It's still not great, but we'll figure it out. All right. So let me go ahead and delete what we had from the last one and put the next one in. So we have x plus y, is less than or equal to 20. And then we have 14x plus 10y is greater than or equal to 150. All right, so this time we have green and we have red, okay? Once again, I only want to focus on the section that is overlapping, which actually happens to be in between the lines this time. So when I go to choose my combinations, I want to make sure that I pick points that are in between. So like, for instance, this point right here works. Okay, so that is 10, and x is number of hours on the morning shift. So 10 hours morning, and that would be 2, 4, 6 hours afternoon. All right, now we can pick a point on the axis if we want to here. Let's say we pick this one right here. So that's 10, 12, 14, 16 hours in the morning and no hours in the afternoon. Or say she's not really a morning person and she wants to do just afternoon hours. So she could do that. So it would be 0 hours in the morning. And that would be 18 hours in the afternoon. And of course, there are more options than just those three, but all three of those work perfectly for this problem. Okay, we have one left. Let me refocus one more time. Okay, here we go. In order to prepare for your summer bash, you go to the supermarket to buy hamburgers and chicken. Hamburgers cost $2 per pound and chicken costs $3 per pound. You only have $30 to spend and know that you need to purchase at least 3 pounds of hamburgers. Let X represent the number of pounds of hamburgers you buy, and Y represent the number of pounds of chicken that you buy. All right, same 3 questions. So when I go to write my system, once again, I have 2 different totals here. You only have $30 to spend, so only have $30, and you know that you need to purchase at least 3 pounds of hamburger, okay? So let's start with the money. X is number of pounds of hamburgers, and each pound of hamburger costs $2. So 2x plus it's $3 per pound of chicken, that's 3y, and you only have 30 bucks. So the amount that you spend here has to be smaller or equal to 30. Now this second inequality is the tricky one. You need at least 3 pounds of hamburger. It doesn't say anything about chicken. So I'm not gonna have a y in this inequality, it's just x. So I know that the number of pounds of hamburger I buy has to be bigger than or equal to 3 pounds. So that's my second inequality. All right, let's go ahead and graph. Once again, you're gonna see the problem that we just did before I reset. So let's let it focus, and then I will delete this one and put the new one in. All right, so we have 2x plus 3y is less than or equal to 30. And the second one is x is greater than or equal to 3. Okay. So this one's a vertical line, which makes sense because it's only x. It has nothing to do with y because we need 3 pounds or more of hamburger. Okay. So my 3 combinations are going to come in this little triangle area here. So let's pick 3 combinations. Let's see. I could do, let's say I just want to do hamburger. I could do, I don't know, 12 pounds of hamburger. And no pounds of chicken. Or I could do, let's do this point right here. So that would be, let's see, 0, 2, 4, 6 pounds of hamburger. And 4 pounds of chicken. Or I could pick a point on the line here, that would work. Oops. No, you can still see it a little bit here. Let's do, I don't know, this one looks okay. No, I gotta put it back, okay. I don't know, let's do this one. So that's gonna be 8 pounds of hamburger. And 4 pounds of chicken. Notice that I cannot choose a number of pounds of chicken without any pounds of hamburger. Because remember what we said, we have to have at least 3 pounds of hamburger. So it's impossible to buy only chicken in this case, okay? So let me show you the combinations I chose, and obviously there are others you could pick, but these are just the ones that I went with. So there they are, and that's it. That's how you write systems of inequalities, use DESMOS to graph them, and find solutions in the context of the problem.